Hello students, friends. Now in this session also you can solve some problems related to FET. So these are the formula used in order to calculate the different parameters here. So I given the formula used for this session. Now in first problem, an amplifier has a gain of 20 without feedback, and if 10% of the output voltage is feedback by means of a resistive negative feedback, determine the actual gain. So given data is gain without feedback, then feedback factor is given, that is 10%, then you can determine the gain with feedback. So this is a negative feedback, and therefore the formula used, gain with negative feedback is equal to gain without feedback AB upon 1 plus AB beta. Now you substitute all the factors here, then you can get the gain with feedback is 6.67. So this is one problem. Now I can see in second problem, the overall gain of multi-stage amplifier is 140, means gain without feedback, that is AB is given. When the negative feedback is applied, the gain reached to 17.5, means gain with feedback is 17.5. Find the fraction of the output that is feedback to the input, means you have to calculate beta value. Again same format use. Now you have to modify this and calculate beta is equal to. So by substituting all these gains, the final result will be get 0.05. So after giving problems, first to write the given data, then you come to know what given and what to calculate. Now in third problem, in a negative feedback amplifier, gain without feedback 100, feedback factor is given 0.04, and voltage, that is Vs, 50 milliampere. Find gain with feedback. Gain with feedback can be calculated by using formula AB with feedback. AB is without feedback, gain without feedback, and simplify this one, you can get 20. Then output voltage is equal to feedback into your source voltage, and that can be taken as 1 volt you get. Then feedback factor is gain multiplied by your fraction beta value, that can be calculated by using this formula, and therefore get 4, and feedback voltage you can get 0.A0 here calculated here. A0 value is 1, that is you can write here bit here V0, then it becomes 1, and therefore you can get feedback voltage is 0.04. So next in Hartley oscillator, the C is equal to capacitance is equal to 250 picofarad, L is equal to 1 millihenry. In each part, calculate the operating frequency of the oscillator, neglecting the mutual inductance. So given data is given, C is equal to 250 picofarad, L1 is equal to 1.5 millihenry, L2 is equal to 1.5 millihenry, each it is given, and therefore total inductance is equal to 3 millihenry. And now I can calculate the frequency by using the standard formula 1 upon 2 pi square root of LC. So if you substitute all these things, you can get the final frequency, operating frequency becomes 183 kilohertz. So in case of FET, now I can say again, if a change in drain voltage is 3 volt, produces a change in the drain current 0.03 milliampere, change in source voltage is 0.1 volt, causes a change in drain current 0.3 milliampere. Calculate drain resistance and transconductance. Change in drain source, then drain current, change in gate source, and change in drain current. So drain resistance is equal to change in drain source voltage to the change in drain current. So simply can substitute all these values, you can get 100 kilo ohm. Then transconductance is equal to change in drain current to the change in gate source voltage. So that becomes substitute here, you can get milliohm. Next, if amplification factor of FET is 4.5, calculate the mutual conductance if the drain resistance is 205 kilo ohm. So mu value is given, RD is given, so straight we can calculate the conductance. So that is mu is equal to RD into GFS, and therefore simplify and you can get the result 1.8 into 10 to the power of -3 moles. So these are some of the problems related to transistor FET and all. Thank you.